Welcome to today's class, Exponential Inequalities. In that term, first we learn exponential function, right? What is exponential function? If suppose you take y is equal to f of x is equal to a power x, okay? A power x is the exponential function where a greater than 0 and a is not equal to 1 here. The base is always positive and not equal to 1 is called the exponential function of x, like where x belongs to r. The input values what you are going to give is all real numbers you are going to give. Okay, fine. This is what you call exponential function. A should not be negative because you know that if a is minus 2 for example and x is 1 by 2, square root of minus 2 is imaginary quantity. That's why this is not defined. That's why see a power x, you have a is positive, a is not equal to 1 and x belongs to r, like this. Now first of all let us draw the graph of the exponential function in two cases. One is when a greater than 1 here a greater than 1, like this. I have taken like this a table for your understanding purpose, better understanding purpose, x 2 power x. Here the base a is equal to 2, like this, right? Once we have got this, x is 0, 2 power 0, 1. X is 1, 2 power 1, 2. X is 2 means 2 power 2, 4. X is 3 means 2 power 3, 8. So on like this. And when x is minus 1, 2 power minus 1, 1 by 2. When x is minus 2, 2 power minus 2, 1 by 4. When x is minus 3, 1 by 8. So on it goes up to 0, like this. Now those only we will plot on the graph. Now this is what negative x-axis you are having here, and this is what you have positive x-axis, right? This is positive y-axis, that is plus infinity, and this is minus infinity and it is negative y-axis. This is what the total coordinate system, coordinate plane of coordinate plane, this. Now let us plot the points. When x is 0, y is 1. This is what the point now you have got here, 0 comma 1, and this is point 1 comma 2, like this, and this is the point 2 comma 4, and this is the point 3 comma 8 we have got, and this is the point you have got here minus 1 comma 1 by 2, and this is minus 2 comma 1 by 4, like this, right? And when you keep on going like this, it will comes nearer to 0, like this, right? But it won't touch 0, but it will be okay. When you join all these points like this, it is a strictly increasing curve. You can observe the shape of the graph of this exponential function will be like this. It is a strictly increasing function. You have got that. It will start from here, like from minus infinity, like this. Okay. It will never take negative values. The exponential function whose output values, it will never give you negative values, always positive. That's why from it is above x-axis, and it rises towards infinity. This is what the graph of the exponential function a power x when a is greater than 1, like this. As for understanding purpose, we have taken a equal to 2 such that you can understand in a better way, like this, right? Now we are going to get the graph of right, a when it lies between 0 and 1, like that. You see, now when we are try to plot the graph of y is equal to a power x when a is 1 by 2. Here 1 by 2 we have taken like this. When x is 0, 1 by 2 whole power 0 become 1. When x is 1, 1 by 2 whole power 1 is 1 by 2. When x is 2, it is 1 by 2 whole square, that is 1 by 4. When x is 3, 1 by 2 whole cube, that is 1 by 8. Like that, so on it will go. When this is increasing like this, so on up to infinity, it will come nearer to 0, like this. When x is minus 1, it become 1 by 2 whole power minus 1, that is 2. And x is minus 2, that is 1 by 2 whole power minus 2, that is 4. When x is minus 3, this is 8, so on like this. When x is like something like minus infinity, it will be nearer to plus infinity, like this, right? It will be a plus infinity. When it is minus infinity, it will become plus infinity, like that, right? This is what you have here. Now This is right, negative x-axis, positive x-axis, positive y-axis, negative y-axis. Like this we have got the coordinate plane, this, right, x-axis and y-axis. Both are real number lines intersected perpendicularly, that you know. 0, 1, this is what the point 0, 1 you have got like that. 1, 1 by 2. 1, 1 by 2 will be here like this, right? And 2, 1 by 4, it will be very much down part. And 3, 1 by 8 still like that, and it will be like this. And minus 1 is what? Minus 1 value is 2, right? Minus 1 value will be 2 like this. Minus 2 will become 4. Minus 3 become 8 like this, right? You see, my dear students, once you plot, the graph is strictly decreasing function like that. Okay, when it lies between 0 and 1, this is what you have, the graph of y is equal to a power x. When a lies between 0 and 1, it is a strictly decreasing function like that. Okay, we have plotted these points and we have observed that. Okay, whereas a power x, when a greater than 1, it is a strictly increasing function, right? What we have got, suppose a power x, y is equal to a power x, when a greater than 1, in the same graph, let us try to make it once again, means it will be like this. This is what a power x, when a greater than 1, like this. This is a power x, when it lies between 0 and 1, like this. This is what the graph of this, and this is what the graph of this, right? This is the way how we will have the graph of the exponential function when the base lies okay, when the base greater than 1 and base lies between 0 and 1. These are, one is strictly increasing and the other one is strictly decreasing graph we are having here, right? Now we will discuss about some of the properties of the exponential function, okay, inequalities, to do this, and afterwards we do certain problems based on that. It's a very interesting topic, such that because in already you did logarithmic inequalities, you feel it will be very much better, right? Now we will start. Okay, properties of exponential function. Let us discuss these in the form of sets. Set 1, right? These are the basic formulas in exponentials, you know already. That is, a power x equal to a power y means once the bases are equal, then you can equate the powers. That is what you have got, x is equal to y, right? And the second one is a power x is greater than 0. As we told you that when a is positive and a is not equal to 1, that positive power, any real number, will be always positive. This is very important, like that, right? Now the third one, a power x into a power y is equal to a power x plus y, because when bases are equal, you can add the exponents. Fourth one, a power x by a power y is equal to a power x minus y. When a power y comes to the numerator, it becomes a power minus y, then a power x minus y. Now the fifth one, a power x whole power y is equal to a power xy, right? And this a power xy also we can write as a power y whole power x. Okay, these are the basic equations you know already in your lower classes. Now the sixth one, a power log x to the base a equal to x. This is very much known from logarithms, right? This a power log x to the base a equal to x. Seventh one, now ab whole power x is equal to a power x into b power x, right? Eighth one, a by b whole power x equal to a power x by b power x, right? Now a power x is equal to 1 by a whole power minus x, we can write this, right? Because this is nothing but 1 by a means a power minus 1 whole power minus x. This is now a power x. Minus 1 into minus x become x, like this. And 10th one, 1 by a whole power x is a power minus x. So because you know that 1 power x is 1 by, this is a power x, you can write, and this become a power minus x. These are some important exponential formulas, very important to do these all problems, right? Now we have set of inequalities, exponential inequalities, my dear students. Set 2, that we take if a power x is greater than 1, like this, right? A power x is greater than 1, it become, okay, x become positive if a is greater than 1. Suppose let us take here a equal to 2, right? Now 2 power x is greater than 1 means x is positive, what they are saying that. This become very obvious that 2 power x is greater than, we can write it as 2 power 0 like this. 1 we can write as 2 power 0. That means once the base is here greater than 1, what we will have that x is positive like this. X is positive, we can have like this. Okay, 2 power x is greater than 2 power 0 means x will be positive. In the same case, when a less than 1, that means a cannot be negative, but it lies between 0 and 1 like this. That means a equal to, you take 1 by 2 like this. Now 1 by 2 whole power x is greater than 1, right? And that you can write it as 1 by 2 whole power x, you can write it as 2 power minus x is greater than 2 power 0 we can write, right? That means here the base 2 we are having here, then what you are going to have is minus x is greater than 0. Now you multiply by minus sign on both sides, then you will have that x is less than 0. Okay, by that we have got this particular one, and by this we have got this particular one like this, right? Therefore, in this way we will be doing this inequality result under set 2 first one. When we will have equal to 1, like the second one, in this a power x greater than or equal to 1 means when you have that when a greater than or equal to 1 here like this, when you will be having that this means when this will be greater than or equal to 0, a should be greater than or equal to 1 like that you should have. And another one, when you will have x lesser than or equal to 0 means a will be lesser than or equal to 1 like this. In these cases equality is when it will be equal to 1 means that you know it is obviously that right, when 2 power x is equal to 1, when it will happens means when 2 power 0, that means you are going to include that x equal to 0 is also got included like that, right? 2 power x is equal to 1, that means that equal to 2 power 0, that means x is equal to 0, you are going to include in both the cases like this, right? Even similarly 1 by 2 whole power x is equal to 1, then when it will happen 1 by 2 whole power 0 like that, that means x is equal to 0, you are going to have like this. Okay, the second case in set 2 will be answered like this. Fine. Now the third one under set 3, a power x is less than 1, when it will happen means okay, x become less than 0 if a greater than 1 like this. A power x is less than 1, that implies x is less than 0 if the base is greater than 1 like that, and it is greater than 0 if the base lies between okay, that means a less than 1. A less than 1 means if it lies between 0 and 1, that is what the meaning of it. Let us illustrate with some numbers, then we can understand in a better way like this, right? Here you take a is the base 2 which is greater than 1. You know that 2 power x is less than 1 we have here the given problem. 2 power x is less than 1, that means this is 2 power 0, that means 2 power x is less than 2 power 0 like this, right? That means you have x is less than 0 like this. You have here x is less than 0, that's what we have got. X is less than 0 if a greater than 1 like this, right? And one more thing here, x is greater than 0 if lies between 0 and 1. Let us take here a is equal to, for our understanding purpose, it is 1 by 2 which lies between here 0 less than 1 by 2 less than 1 like this. Once you take like this here, 1 by 2 whole power x is less than 1. This is what 2 power 0. Now this is 2 power minus x is less than 2 power 0 like this. And here since the base 2 is okay greater than 1, we will have minus x is less than 0 like this. And this minus x is less than 0 you have got means you multiply, because we need positive x, you multiply by negative sign, then you will get x is greater than 0 like this. Therefore x is greater than 0 if the base a is lying between 0 and 1. As here we have taken a as 1 by 2. I think by these illustrations it is very clear that this inequality result is perfectly correct like that, right? Fine. Now you see one more thing, my dear students. Under this only, the fourth one, if you take, when it will be equal, like lesser than or equal to, when x is lesser than or equal to 0, okay, when x is greater than or equal to 0, here this way is greater than or equal to 1, like this you are going to have like this. When you have equal symbol with 1, when a is 1, like, then 1 power x is 1, like, right, x is a finite number, like that. Okay, when you will have equality means when x is here equal to 0, when x is 0, that you will be getting it as 1, right? Fine. Similarly, when a is 1, like that, you will be having that as 1. In this way, you will be having this set of inequality results, right? Now we have set 3. These results very important while we are doing these exponential inequalities problems, right? See, a power, the first one, a power x is greater than a power y. That implies that x is greater than y if a is greater than 1, right? And x is less than y if a lies between 0 and 1. Let us illustrate this with some numbers, then you will be getting very clearly the understanding of it. Okay, the illustrations, if we do, let us take here the first case, a as 2. A as 2. 2 is greater than 1, right? Once you have got like this, my dear students, you see that 2 power 4 is greater than 2 cube. That is obvious, that, right? That implies we can say that 4 is greater than 3. Wonderful. Because here the base a equal to 2 is greater than 1. This is a very common sense understanding of this statement, right? This is what the first one we have got like this. Now the second one, you take a as 1 by 2, 1 by 2. That means this is lying between 0 and 1, like this. You take this lies between 0 and 1. Now you take that here, right? 1 by 2 whole power, right? We take here whole square is greater than 1 by 2 whole cube. That is fact. Why it is fact? 1 by 2 whole square is what? 1 by 4. 1 by 4 is greater than 1 by 8. That is obvious. That means when the base lies between 0 and 1, you have got that x and y. Here what you have got? 2 less than 3. That is the fact. X is less than y. Here x is less than y you have got like that. When the base is 1 by 2. 1 by 2 means what? It lies between 0 and 1, like, right? When it lies between 0 and 1, we have got this wonderful inequality, right? That means, let us recall once again, a power x is greater than a power y. Okay, if a is greater than 1 means x is greater than y. If a lies between 0 and 1 means x is less than y, like this, right? These all we have illustrated with nice numbers, right? We take a equal to 2, 2 power 4 greater than 2 cube. That means 4 greater than 3, like. When a is 1 by 2, you have got this. This is the way how you will be doing in this. Now in step 3, the second one, when you will have greater than or equal to, like this, right? When you will have greater than or equal to means when you have x is greater than or equal to y here, and here when x is lesser than or equal to y, you will maintain this result like that. When you have, right, greater than or equal to, then you will be having that thing like this. When we will have equal to means when x equal to y, a power x equal to a power y. That is obvious. When x equal to y, a power x equal to a power y. That is very true, very much true. That means when x is equal to y, a power x is equal to a power y, right? This is obviously true, and less than and greater than will be maintained according when x greater than y or x less than y based on their basis, right? Now the third one in this, a power x less than a power y. This is, you know that when a base is greater than 1, it will maintain the same, the powers also maintain same inequality. X is less than y. If the base lies between 0 and 1, then x is greater than y, like that. We can illustrate this with some nice examples. 2 power x is less than 2 power y, right? That means 2 2 power 3 less than 2 power 4. That is a basic fact. 8 is less than 16. That means when base is greater than 1, we know that 3 is less than 4. Therefore, we have got that, right? X is less than y when a power x is less than a power y when the base is greater than 1. Right, my dear students? Now, the same thing when the base lies between 0 and 1. Right? A less than 1. 1 by 2 whole cube is less than 1 by 2 whole square. That is 1 by 8 is less than 1 by 4. It is a basic fact. When it is there like that, the powers x is 3, y is 2. That means 3 greater than 2. That means x greater than y we have got. When the base lies between 0 and 1, it maintains a different inequality which is opposite to the inequality which is present here. That is what our observation in this case. Right? When a greater than 1, it maintains the same inequality. Less than means less than. When it lies between 0 and 1, it maintains the opposite inequality. If it is less than, here it is greater than. If it is greater than, here it will be less than. That is what we have observed. And one more thing, when we will have it, we take it as a fourth one, equal to. Equal to means we know that when x equal to y, it will maintain a power x equal to a power y. Here also, when x is greater than or equal to y, you will have, even if the base is lying between 0 and 1, x is greater than or equal to y, a power x lesser than or equal to a power y. And x is lesser than or equal to y when a greater than 1. This is the fact that we have got under this set 3 results. Right? Now another set 4, we have the first one, a power f of x is greater than a power g of x. Here f of x and g of x are any algebraic expressions. That same like if the base is greater than 1, dear students, then f of x will be greater than g of x. Right? As we have discussed in the previous one. If the base lies between 0 and 1, then f of x will maintain less than g of x. As I told you that if the base lies between 0 and 1, right, here you have greater than, here it becomes less than. They maintain the opposite inequalities. When the base is greater than 1, they maintain the same inequalities. Right? This is the fact that you have got. For example, we have got that something 2 power x square is greater than 2 power 3x plus 1. Right? Here the base 2 is greater than 1. We can easily say that x square is greater than 3x plus 1, my dear students. Right? This is what one of the fact here. And another thing is that if suppose you have 1 by 2 whole power x square is greater than 1 by 2 whole power 3x plus 1. Here since the base is lying between 1 by 2 is lying between 0 and 1, the fact that you are going to have x square is less than 3x plus 1. And you know how to solve this. And you know how to solve. This is a quadratic expression that can be solved beautifully. You read n number of problems on these particular cases. Right? Fine. The same thing now, dear students, another set if we discuss that, suppose a power f of x is less than, here you have got. When base a greater than 1, you will be having here less than. And when base lying between 0 and 1, I told that it will maintain a opposite inequality. Right? And this is also better you can understand, right? When you have this less than here, when we will maintain here, this is less than inequality. 2 power x square is less than 2 power 3x plus 1. When the base is greater than 1, then x square is less than 3x plus 1. And similar way, when the base is 1 by 2, right? 1 by 2 whole power, this is x square is less than, you have here, then it will maintains here x square is greater than 3x plus 1. Right? This is what another set of inequality under this set 4 we have. Now we have one more inequality. By this we will conclude. In the next video we will be doing very much interesting problems on these exponential inequalities. Right? Now set 5, last one. The first one what we have under this is a power x is greater than b. Right? Then when base a is greater than 1, right? When base a is greater than 1, then x is greater than log b to the base a. You know that, my dear students, how to convert into logarithm. A power x is equal to b means x equal to log b to the base a. That is the fact here it is mentioned. a power x equal to b means x is equal to log b to the base a. Now instead of equal you have here a power x is greater than b. Then x is greater than log b to the base a if a is greater than 1. And if the base a lies between 0 and 1, then x is less than log b to the base a, right? That we can understand clearly these illustrations. 2 power x is greater than 3, that implies x is greater than log 3 to the base 2 if the base a is greater than 1, right? Here base is 2, right? And second one is base is here 1 by 2, that lies between 0 and 1. 1 by 2 whole power x is greater than 3 means x is less than log 3 to the base 1 by 2, right? Log 3 to the base 1 by 2. Right, now in the same way the second thing we will get that from here. The second one is a power x is greater than or equal to b, right? Greater than or equal to b, when it will be maintained is when x is greater than or equal to this and a greater than or equal to 1, when, and this is lesser than or equal to when a lesser than or equal to 1. Equal to symbol is maintained in this way, right? Now we have third one, a power x is less than b, right? That implies when the base a is greater than 1, x will be less than log b to the base a, right? If the base lies between 0 and 1, x is greater than log b to the base a. That means this less than will be, and here it will be greater than. As I told you that they maintain opposite inequalities. That we can easily illustrate, right? We can easily illustrate the things. 2 power x is less than 3. That implies x is less than log 3 to the base 2 if the base is greater than 1. Here the base we have taken as 2. That's why x is less than log 3 to the base 2. And the second one, 1 by 2. Here the base lies between 0 and 1. Then 1 by 2 whole power x less than 3. That implies x is greater than log 3 to the base 1 by 2. As we told that they maintain opposite inequalities when the base lies between 0 and 1. This is the fact. Right, now the fourth one, if you take here the fourth one, the last one, equal to, here when it is equal, when it is lesser than or equal to, when it is greater than or equal to, here it is greater than or equal to, like this, a is not equal to 0, it is lesser than or equal to 1. A power x is lesser than or equal to b, when it is true means when x is lesser than or equal to log b to the base a, when a greater than or equal to 1, and equal to maintained when a equal to 1, and this is maintained like this. When a equal to 1, my dear students, you know that when a equal to 1, you know, remaining things you will get as it is like this. Fine, right, my dear students, these are the some set of results we have got in these exponential inequalities. You repeatedly watch and you will get a perfect clarity how to use these inequalities on observing those problems. Thank you very much. Thank you for watching. Please subscribe, share it and like it, right? Thank you very much.